Bolt classes. What are they and what do you use them for? If you've never heard of classes, they are essentially containers for your code. They have variables, functions, and events. In Bolt 2, all of your code will now exist inside of a class, just like it does for C#. With Bolt, there are a few different flavors of classes, and if you're just getting started with Bolt or Unity, that can be a bit confusing. So let's try to reduce some of that confusion and walk through the options. But before we get too far into the video, I want to give a quick shout out to Just Create for donating the background art. Check out their fantasy medieval village on the asset store in the link below. But let's get back to the topic of this video, which is Bolt classes. For this tutorial, I'm assuming that you have Unity open and that you have Bolt 2 installed in your project. If you don't, check out my earlier videos on how to do just that. So to create a Bolt class, you right-click in your project folder and select Bolt. And you should be getting 3 options, or at least at the time of recording, there are 3 options. You'll get Bolt class, Bolt asset, and Bolt enum. The first option is what most of us will be using the majority of the time. That is a Bolt class. A Bolt class is very similar to a C# script in that it is a container for variables, functions, and events, just like mentioned before. Or in other words, it's just a container for all of your code. All of the coding that you will be doing in Bolt 2 will be done within a Bolt class. A Bolt class can then be attached to a game object via a Bolt component. It is this Bolt component that allows the code to exist on a scene object or a prefab. Once the code is on an object, that code can then be used to control that object or whatever else it might need to do in your scene. A Bolt class can also exist in your project folders. It does this by being attached to a Bolt asset, which is the second option that we can see. Now for some, it may seem odd, strange, or even useless to have code sitting in your project, but it can actually be amazingly useful. In particular, this can be super useful for data, which was challenging and a sore spot in my opinion with Bolt 1. For example, it can be used to define character stats, spells, or even code that may define how a particular entity functions. To give a more concrete example, I've created 3 Bolt assets for different weapons. The Bolt asset is then host to a Bolt class that contains basic weapon data such as damage, cost, and weapon type. This means that the data exists in my project. It is not attached to a scene object or a prefab. The real bonus with doing it this way is that any object that needs to know about a particular weapon can have access to this singular chunk of data, which can greatly simplify your code, albeit at the cost of some abstractness. To be clear, this is not a simple idea. Bolt assets are definitely an intermediate to advanced topic, but they're well worth learning about, and I'll definitely be taking a more in-depth look at Bolt assets in a future video. If you've been using Unity for a while, this role might sound familiar. Bolt assets are functionally identical to scriptable objects, and if you want to learn more about those before I put out a Bolt-specific video, then check out the video I did on scriptable objects over on the DevDog channel. The video looks at what scriptable objects are and how they can be used in your project. Any way that a scriptable object can be used in your project, you can also use a Bolt asset to do the identical thing. Let's talk about the last option, which is the Bolt enum. This is a feature that was missing, or at least I couldn't find it in Bolt 1. This allows you, the Bolt user, to define an enum without having to use a C# script. Now there are a ton of uses for enums, and yes, they get overused, but I'm excited that my students will have easy access to these in the future. You may have noticed on my weapon data, there's a drop-down for weapon type. This is a Bolt enum where I've defined a handful of weapon types. In this case, the enum provides a convenient way to categorize or classify different weapons. In my personal project, I'm using an enum combined with events to control or trigger mode changes in the game. Albeit, I'm using C#, but the same idea can be done with Bolt 2. This approach has hugely simplified my code by decoupling or despaghettifying my code base. Game objects simply listen for a change in game mode and then do what they need. And yes, of course, this is on my list of ideas for future videos, as well as covering other programming patterns that are now much easier to create in Bolt 2. So let's dive into the Bolt class itself, as there are still more options buried inside. In the Explorer, or in the Inspector, we can see that each class has a scope that can be set. For most uses, you're going to want the component scope, as this scope allows the class to be dropped into a Bolt component so that it can exist on a scene object or a prefab. For many simple projects, this may be all that you will need. For example, here you can see a Bolt component with a Bolt class attached to a cube. In the Explorer, you can see the code running, and in this case, the code is simply spinning the cube and making it move slowly up and down. Moving down the list, the asset scope is used with the Bolt asset to create code that is a project asset, as talked about earlier. Only classes with the asset scope will work with the Bolt asset. The scene scope is a clever addition to Bolt 2. Any class that has their scope marked as scene will be guaranteed to only have one copy in the scene, and you don't need to add it to the scene manually. Bolt will do the work for you. This can help declutter your hierarchy while maintaining functionality, which can be increasingly difficult to do as a project grows in complexity. A scene-scoped class could be great for game managers. For example, you may have a music manager that holds references to audio clips and has code that can be called to play the background music. And finally, the singleton scope. This is similar to marking a class as static in C# and will ensure exactly one instance of the class exists in the entire project. This can be used for classes that need to be accessed everywhere or that contain global data. A singleton scoped class can be useful for storing helper functions that may be frequently used by code throughout a project. Again, in my personal project, I use similar functionality for things like rounding a vector 3, getting a random float between given values, and other more project-specific functions. And once again, this helps declutter my code and keeps the code base small as I don't have to repeat code over and over. So that wraps up the different types of classes and hopefully gives you some idea of when and why you might use each type. But I do want to go a bit further, as there are still more options to be found when using Bolt classes. In the Explorer, if you right-click on a class or look at the editor for a class, you will see several more options. And in this video, I just want to look at the graph options. Adding variables is pretty straightforward, and events, well, those are a bit more involved and deserve their own dedicated video. But back to the topic of this video. As mentioned, classes are just containers for code, and that actual code will exist within graphs. Which means our classes, if they're going to have code in them, are going to need to contain graphs. And we can see that we have 4 options of different style of graphs. The first option is a flow behavior. This is the most commonly used type and corresponds closely to a mono behavior in C#. This type of graph will support events such as start and update that get called automatically by Unity. In general, most classes, especially component scoped classes, will have at least one flow behavior, and this is the type of graph that was used earlier in the spinning cube. The next option is a flow function. This is new to Bolt 2, but plays a similar but not exactly the same role as super units in Bolt 1. These graphs do not support events such as start and update. Rather, they must be called manually by adding them as units into other graphs. This makes for code that can be easily reused and can help to declutter or reduce the number of units in other graphs. A good rule of thumb is if you are repeating the same set of commands more than twice, you should think about putting them in a function. Or each chunk or behavior of your code can be wrapped into a function for better readability. Functions also make your code easier to maintain since all the code is in one place. Whereas if you didn't use functions, you would need to update each and every instance of those chunks of commands. A good example of a flow function is from an upcoming video on the rollerball tutorials. In these videos, I'll create a flow function that updates a UGUI text object to show the player's score. This gets called in multiple places, so it's a perfect candidate for a function. The third option is a flow macro. These will support events like start and update, but they also support input and output ports like a flow function. And these are nearly identical to super units with Bolt 1. You can kind of think of these as a combination of flow behavior and flow function. I'm not sure I'm going to be using flow macros very often. I feel that flow behaviors and flow functions are going to fill my needs pretty well, but I could be wrong, and it's nice to have the additional option. There's a subtle and important note to make on flow functions and flow macros. After all, they both behave similarly to super units, and that note has to do with the values that get passed in. Flow functions will make copies of the data that gets passed in, whereas flow macros will go back into the flow behavior and fetch the data. This can lead to unexpected errors or issues. Going into depth on this is a bit beyond the intended scope of this video, but is worth being aware of and could easily be a video all on its own. Now our last option here is the state behavior. This is exactly like the state macro from Bolt 1 and allows the creation of finite state machines. These can be particularly helpful when trying to create something complex like AI behavior. For example, an NPC might patrol, chase, and attack the player. This would be a perfect use for a state behavior, as the NPC is either patrolling, chasing, or attacking, and not both or any sort of superposition of those states. In my experience, state graphs are underused and underappreciated. I think this comes from the fact that state behaviors add one more layer of complexity. But if you find yourself struggling to control whether this code or that code runs, and your stack of if statements is getting impossible to manage, then it might be time to use a state behavior. That said, it's probably not surprising, as I keep saying it, state behaviors are worthy of at least one video all on their own, and it's on my list of future video ideas. So there you go, that was a really quick trip through all the class options in Bolt 2. Clearly, there are more options than with Bolt 1, which has brought new functionality but has also added some complexity. Choosing the correct type and scope of class depends on the task that you're trying to complete, and the more you use Bolt 2, the easier it will get. So I hope that was interesting and, better yet, useful for your project. If it was, think about hitting that like or subscribe, or if you want to go further in supporting the channel, check out the links to my Patreon and Discord in the description below. So until next time, happy game designing.